Checkpoint exercises for representing relations. With number one, we're given a set of ordered pairs, and we're asked to represent those ordered pairs both in a table and in a graph. So I've went ahead and written out the ordered pairs again. With the table, we simply put the x values in the x column of the table and the y values in the y column. So we'll start off with, let's put these in order. -8 is smaller than -3, so -8, -3, 5, and 9, and then the corresponding y coordinates. With -8 we have 7, with -3 we have -4, with 5 we have -7, and with 9 we have 4. And then it's just a matter of counting x and y to graph the coordinate pairs. Each one of the tick marks represents 1, so our first one we're looking at -8, so -1, -2, -3, -4, -5, -6, -7, -8 is going to be right here. And then we go up 7, so 1, 2, 3, 4, 5, 6, that's that last tick mark. Then -3, -4 is going to be -1, -2, -3, and then down 4, so 1, 2, 3, 4. So right here is going to be -3, -4. 5, -7, so 1, 2, 3, 4, 5 to the right, and down 7. That's going to give us a mark right about here. And then last but not least, 9, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So our points graphed are going to be those 4 points there. And then we're asked to state the domain and range. Again, the domain is simply our x coordinates. So domain is -8, -3, 5, and 9. And our range is just going to be our corresponding y values. So -7, I'm putting them in order. -4, 4, and 7. So there are our domain and range. Again, the table, we just simply list the x coordinates in the x column. I put them in order. That's not necessary, but it is advised for purposes of the domain and range and for graphing for that point to go from left to right. The y values we put in our y column. Then we simply graph those points by counting in the x direction and then the y direction. Left if it's negative for x, right if it's positive, down if it's negative for y, up if it's positive. And then the domain and range are simply the sets of each of those values, the domain being the x values and the range being the y values. Now with number 2, we are given a table. We're asked to describe the pattern of any in the table, write the ordered pairs x, y, graph the coordinate pairs on a coordinate plane, describe the graph, then finally state the domain and range of the relation represented. So if we look at our table, we should notice a pattern that each subsequent number is multiplied by the next highest value. So in other words, 2 times 3 equals 6. 3 times 4 equals 12. 4 times 5 equals 20. And 5 times 6 equals 30. Now in the x direction, we'll go ahead and make this scale 1. In the y direction, we'll go ahead and make each one of the tick marks equal to 5. So then we plot our points. 2, 6 would be right about here. 3, 12 is going to be right about here. 4, 20 is going to be right about here. And then finally, 530 is going to be right about here. Now it says graph the coordinate pairs on a coordinate plane, which we did, and describe the graph. With this, it looks like there's somewhat of a curve. The further we go up, the steeper the curve gets. So essentially that would be our pattern. As x increases, y increases, you could say above linear, since if we drew a line, it would be below where these points are. So it raises in a curve. State the domain and range. Again, this one's simple. It's just the domain is the X values, so 2, 3, 4, 5. The range is the Y values that correspond to those, 6, 12, 20, and 30. All right, last but not least, number 3, we are given that an ice cream factory produces 300 containers of ice cream per hour. We're asked to make a table of ordered pairs where X represents the hours, Y represents the number of containers. Specifically for 5, 10, 15, and 20 hours, we're asked to graph the ordered pairs and then finally again state the domain and range of the relation as it is stated, which means it's limited to just the X values we are given. So you can write this out, but essentially we're just multiplying each X value by 300. So 5 times 300 equals 1,500. 10 times 300 equals 3,000. 15 times 300, if you'll notice, that's just going to be 1,500 more because we're looking at 5 more hours than 10, and 5 times the 300 is 1,500. So this is going to be 4,500. Then add 1,500 more for another 5 hours, which is going to be 6,000. We'll go ahead and graph those ordered pairs. So 5, 1,500. Count 5 to the right. 1,500 up. 10, 3,000. 15 is 4,500. Then finally 20, which is going to be our 6,000. Now we're not necessarily asked to describe the pattern, but if you can tell, it's linear. Our equation would simply just be y equals, it's 300 per hour, so 300 times the number of hours x. That would be what our pattern is. Again, the domain and range are limited to our inputs and corresponding outputs. So the domain is 5, 10, 15, and 20. And our range are the corresponding number of containers. So 1,500, 3,000, 4,500, and 6,000. And again, that's going to be containers. And again, if you have any questions about any of these problems or anything you've witnessed up to this point, just message your instructor. We are here to help you in any way that we can. Just try to be as specific as possible so we're not repeating anything that you do already understand that's already in the content.